Hello guys and welcome to my YouTube channel. This will be the last video of Indian Geography series, and in this video we will be going to cover the climate, and in the climate section we will be looking at the factors that affect the climate of India and how does the temperature and pressure varies over the Indian subcontinent, and also we will go through the monsoon, and thereafter we will cover the soils of India. So starting with climate. So Indian climate is majorly known as monsoonal type of climate. Now we get to see a wide range of variety in various aggregates of the weather like temperature, rainfall, pressure. So these elements of the weather, they vary from place to place in India. Like temperatures in Rajasthan or desert areas, they can be as high as 50 degrees Celsius or more than that even. And in the night the temperature can be as low as 15 degrees. So there are high diurnal ranges difference of temperature, and the temperature in the higher reaches of the Himalayas, they can even go to the minus 30 degrees Celsius. So and in this peninsular plateau and coastal regions there is a slight variation in the seasonal and daily changes in the temperature, that because of moderating effect of the sea and tropical type of climate present there. So their average temperature is around 20 to 25 degrees Celsius. And same about rainfall in the northeastern regions and this western Ghat area, somewhere it crosses the mark of 400 centimeter even, and somewhere it is even less than the 20 centimeter or 50 centimeter rainfall. So this is how the temperature and rainfall varies from area to area in Indian subcontinent. And similarly, the pressure system also changes with the temperature as they are inversely proportional. So now let us look at the factors that are affecting these things. Factors affecting climate. First one is the latitude. That at which latitude a place is located, it affects its climate. How? This is how India is, and roughly like this. And this tropic of Cancer is passing through these 8 states, and below this line the temperature is mainly tropical, and above this the type of climate here is temperate or subtropical. Now second factor that affects the climate is Himalayan mountains. So they are not just the topographical feature, but they also prevents India from the cold Siberian waves and becoming the temperature too less. And they also act as a barrier to the monsoonal winds to escape the Indian subcontinent, and that brings the rainfall to the Indo-Ganga plains and the Himalayan states. Next thing is distribution of land and sea. That I have already told you that temperature in this peninsular region is moderate, and it is moderated by the effect of sea, and here the temperature ranges are more. So this is the moderating effect of the sea. Next factor is distance from the sea. So this is also the little bit of same thing, that The area near the sea, it has more moderate temperature, and in the interiors the temperature differences will be more. Next is altitude. For example, two places are located on a same latitude, like this is some place in UP and this is a place in northeastern India, but this is located on a hill of northeast, that is on Himalayas. So this place will have lower temperatures. Why? Because the temperature decreases with altitude, and in the same manner the pressure will increase. Next one is relief features of an area. So these relief features will affect the temperature, wind speed, their direction, and also the speed of wind. For example, the windward side of the mountain, it receives heavy rainfall, and this leeward side, it falls under the rain shadow zone, and it is a dry region. Now other factors are that are related to air pressure and wind. First one is distribution of pressure and winds. Second thing is upper air circulation, like jet stream. And third one is western cyclones, that are major also known as western disturbances. Now let us look at the mechanism of weather in winter season in India. So what happens to the surface circulations? So in the Tibetan area there will be high pressure. Why? Because the temperatures will be low there, and due to this high pressure the winds will blow from there to the south, that is Indo-Gangetic plains, and this Indo-Gangetic plains area will be under the influence of the dry northwestern winds. Now look at the jet streams and upper air circulations. So western and central Asia, they are under the influence of westerlies whole of the year, that is winds moving from west to east. And now these winds blow across the Indian continent, and they blow roughly parallel to the north of Himalayas. These are Himalayas, and these winds are blowing like this from west to east in upper airs. Now Tibetan highland and these Himalayas act as a barrier to these upper air circulations, that is westerly jet streams, and it is bifurcated into two. It is southern branch blows in south of Himalayas in winter season. They also helps in bringing the western cyclonic western cyclones in India that causes the rainfall. And what are these western disturbances? They are the tropical cyclones that originates over the tropical cyclones originating over the Mediterranean, and they also intensified by the water from Caspian Sea, and they causes winter rainfall in the northern India. Winter rainfall in North India, which is beneficial for the Rabi crops. Now let us look at the mechanism of weather in summer season. That is, in this we are directly going to read about the monsoon. That is derived from the word Monsoon in Arabic, which means reversal of wind system. And how much this reversal is? That is, if the wind deviates from its original course by more than 120 degrees, then it will be referred to as monsoon. Now first let us look at the original conditions. In tropical region, this is equator. This is how the trade winds are blowing. In the northern hemisphere, they are blowing from the northeast direction, and in southern hemisphere, they are blowing from southwest direction. They are converging at an area which is known as ITCZ, that is Intertropical Convergence Zone. Now, as in the summer season, the sun shifts to Tropic of Capricorn in the northern hemisphere, then the position of this ITCZ also shifts northward, which is also roughly parallel around to Himalayas. It shifts around to 20-degree north to 25-degree north. And as this ITCZ shifts parallel to south of the Himalayas, then the southwesterly jet that is present in the winters, it disappears. Now as this ITCZ is shifted northward, then these southwestern trade winds, they crosses the equator and start moving towards the Indian subcontinent, which is monsoon. So now let us look at why does this happens. What are the factors that contributes to the monsoonal type of climate? That is factors contributing to monsoon. First and foremost thing is differential heating of land and sea. We know that the wind moves from high pressure to low pressure. So in the summer season, the land is heated more and it acts as a low pressure area. And this Indian Ocean region and this region around the equator, it acts as a high pressure area. So the wind blows from this direction to this direction, from sea to land. Now remember one basic thing, that any factor that is contributing to increase in low pressure in this North India will help in augmenting the monsoonal type of climate, and anything that is intensifying this high pressure will also intensify the monsoon system. So now moving on to the second point, that is shift of ITCZ. That is, if this ITCZ is shifted 20-degree north to 25-degree north over the Indo-Gangetic plains, then there will be a intense low pressure system that will attract moisture laden wind from oceans, which is southwest monsoon. Now next one is Coriolis force. And how is this affecting monsoon there? These trade winds in southern hemisphere, they are south easterly, that is they are blowing from southeast direction, and as they enters the northern hemisphere by crossing this equator line, so we know that Coriolis force deflects the wind to its right in the northern hemisphere. So this southeastern winds will become the southwest. Southeast trade winds will become southwestern trade winds. Next one is heating of Tibetan Plateau. That is, it is heated more and act as a develop the low pressure center which intensify the monsoon system. Next one is role of jet streams. We have studied that before the onset of the monsoon, this southwesterly jet it disappears. Southwesterly jet disappears. This, this is India. If this is India, then here this a tropical easterly jet appears, which is moving from east direction, and this easterly jet what it does that the low pressure system that develop over the Bay of Bengal region in Indian Ocean, it carries these low pressure system towards the Indian coast, and also this southwest monsoon it shifts its direction and brings it to the Indian subcontinent. So this appearance of tropical easterly jet it also intensify the Indian monsoon. Now there is also small jet which is known as Somali jet, which blows from the Madagascar island of East Africa to Arabian Sea, which brings the Arabian Sea branch of monsoon towards the west coast of India. The next factor is Mascarni high pressure. So this is a high pressure system in the subtropical region near the Madagascar island, which further intensify in the summer season. And if this high pressure system intensifies, then it will push more wind towards the southwest direction towards Indian subcontinent, intensifying the monsoonal system. Now there are some factors that are indirectly affecting the Indian monsoon. They are, you have heard about it, known as El Nino. So remember one thing that it negatively impacts the Indian monsoon. In reverse of its condition is La Nina. That is Humboldt current or Peru current. Temperature of this current becomes further low, and in this El Nino conditions, the cold current disappears and warm currents appear in the eastern Pacific Ocean. So this La Nina condition have positive correlation with Indian monsoon. Another thing is Indian Ocean dipole. Dipole, that is IOD. It has also two phases, that is positive and negative phase. What is the positive phase? This is Indian Ocean, and it's this is cooler. That is eastern side of Indian Ocean is cooler and western side is warmer. This is the positive phase of IOD. Negative phase, western side will become cooler and eastern side will become warmer. This is the negative phase of IOD. So in positive phase of IOD, it will strengthen the monsoon system and bring more rainfall to India. And in negative phase, the monsoon rainfall will be reduced. Now this is about the factors affecting the monsoon. Now let us look at monsoon as a phenomena, that what is the nature of Indian monsoon. In this we will be going to study onset of Indian monsoon. Second one is that is two rain bearing system. Arabian Sea branch, Bay of Bengal branch. Third we will be learning about the retreating monsoon before it we will be doing it break in monsoon. Fourth is retreating monsoon. Northeastern monsoon. So starting with the onset of monsoon. So what does this onset means? It means entering of monsoon in Indian subcontinent. Generally it happens in the June. So it can happen in the last weeks of May and first week of the June. And first of all it enters the Kerala, then it enters Kolkata, and then thereafter it enters the in Indo-Gangetic plains. In this map you can see that this is the area in which monsoon appears in first of the June, that is this Kerala. Thereafter it appears in this Karnataka area. Thereafter this Mumbai, Western Ghats. It also appears in the Kolkata region in 5th June. In northern India, it sets in from 15 June to 1 July. Now it enters from two routes, that is from in this direction. The monsoon system is southwestern in direction, that is moving in this direction. So one branch is Arabian Sea branch and second one is Bay of Bengal branch. So Arabian Sea branch, it feeds the monsoon to Western Ghat region, Kathiawar coast. Now entering from this Kathiawar coast, this winds blow parallel to the Aravallis and it can reach up to the Punjab level. And this Arabian Sea branch, this also enters the rift valley between the Vindhya and Satpura, in which the Narmada and Tapi river is flowing, and it can also enter up to the level of this plateau region. It receives rain from this Arabian Sea branch also. And the another branch is Bay of Bengal branch. So it blows parallel to the Tamil Nadu coast. So Tamil Nadu gets very minimal rainfall from this southwest monsoon and it enters through the Kolkata to India from West Bengal region. Thereafter it reaches Bihar, UP, Punjab, Haryana, Uttarakhand and gives rainfall to these regions. These are the two branches of Indian monsoon. Now next thing is break in the monsoon. So as after the onset of monsoon, the rainfall will continue for 1 or 2 weeks. And thereafter there will be a dry spell of around more, if the dry spell is more than 1 week, then it will be known as break in monsoon. And what are the causes for this break in monsoon? It is that in this western Ghat region, if the winds are blowing parallel to this, then there will be a rainfall break. And in the northern region, if the ITCZ weakens, this is the main reason for break in the monsoon. This retreating monsoon, this is the season from October to November, when the sun start moving from northern hemisphere to southern hemisphere. So this ITCZ weakens and started moving towards the south direction, which weakens the low pressure area of northern India, causing for the reversal of wind direction from southwest to northeast. And they started moving like this direction. And this northeastern system moving from the North India, this northeastern system will pick up the moisture from Bay of Bengal and causes the rainfall in Tamil Nadu coast. So this Tamil Nadu region receives the maximum rainfall from this northeastern monsoon. Now one thing that we have left is pre-monsoon showers that are known by different names. These are the rainfalls that occur before the monsoon arrives in India. Now these are known by different name like mango shower in Kerala and Karnataka. Why? Because they are associated with the ripening of mangoes. Second one is blossom shower is also in Kerala and nearby regions. Third one is nor'wester. It is evening thunderstorms. Thunderstorms in Bengal and Assam, also known as Kal Baisakhi. And in Assam, they are known by the name Bardoli Chiraha. Next one is Lu. These are the hot and dry winds blowing in the northern India in semi-arid and arid regions. Now have a look at these maps. This map shows which region receives how much rainfall from the southwest monsoon, that is in from June to September. So this is the region of high rainfall, that is above 400 centimeter in Western Ghats, and this region of Meghalaya and Assam. And the region that receives rainfall of 200 to 400 centimeters, these are also associated in Western Ghats. In this region of Sikkim, Arunachal Pradesh, Meghalaya, Assam, and from 100 to 200, this other northeastern regions, this Chhattisgarh Plateau, Jharkhand, Madhya Pradesh, UP, Bihar, and West Bengal regions, Uttarakhand also. And this 60 to 100 centimeter rainfall, it is received in the areas of this drier regions of MP, Chhattisgarh, Jharkhand, UP, Western UP, Haryana, Punjab. Thereafter, rainfall decreases from east to west direction generally. And in the interior and in the peninsular plateau, the interior parts receive very less rainfall. Why? Because this region lies in the rain shadow zone of Arabian Sea branch, and also this northeast monsoon is not strong enough to reach this interior parts, so it receives very small rainfall. Now this is the seasonal distribution of rainfall. Now this is how the annual distribution of rainfall in India looks like. This part receives annual rainfall of more than 200 centimeter of Western Ghats and this northeastern hills. This part of Odisha, Chhattisgarh, Jharkhand, Bengal, UP, this region, this receives the rainfall of 100 to 200 centimeters. Majority part of India receives rainfall around 50 to 100 centimeters. And these are the arid regions which receive rainfall less than 50 centimeters. So this is all about the monsoon. Now let us have a look at about the traditional seasons in India that are given in this NCRT. Traditional seasons. They are six. That is Vasant, Grishma, Varsha, Sharad, Hemant, and Shishir. This Vasant is the time of March to April, and in according to Indian calendar, it is Chaitra and Vaishakh. Grishma is May to June, May to June. That is Jyesht, Asad. Varsha is July August, which is Shravan and Bhadrapad. Sharad is September and October, which is Ashwin and Kartik. Hemant is November to December, which is Magh, Shir, and Pause. Shishir is January to February. This is Magh and Falgun. Now let us move towards the soils of India. Now in the ancient time, the soil were classified into two main groups, that is Urvara and Usar. Urvara is fertile land, it is barren land. Now on the basis of genesis, color, composition, and location, the soil has been classified into 8 types, that is alluvial, black, red and yellow. Fourth is laterite. Fifth one is arid. Sixth one is saline. Seventh one is peat soil. Eighth is forest soil. Starting with alluvial, it covers around 40% area of India. It is depositional, found in the area of Indo-Gangetic Plain regions, and it varies from sandy to sandy loam to clay. They are rich in potash and poor in phosphorus. Now it is divided into two parts, that is Bangar and Khadar. Khadar is a new alluvium that is renewed every year, and it includes fine soil deposits and silt. This is new alluvium, and Bangar is old alluvium. It contains calcareous deposits that are known as conchords. Remember one thing, the sand content in the alluvium soil decreases from west to east, and the color of this alluvium soil, it varies from light gray to ash gray. It is cultivable land and it is mostly used for farming and cultivation. Now moving on to the next one, which is black soil. It covers the most part of Deccan Plateau. Also known as Regur or black cotton soil. Black cotton soil. It is generally clayey in nature, that it retains water for a longer period of time, and when it dries, it develops cracks in it, which is referred to as its self-flowing characteristic. It sustains majorly the rain-fed crops. It is rich in lime, iron, magnesia, and aluminium. Also contain the potash, but lack in phosphorus, nitrogen, and organic matter. Organic matter. Color is generally black, sometimes dark gray. Third one is red and yellow soil. Generally occurs in areas of low rainfall in eastern and south part of Deccan Plateau. So it develops a reddish color due to diffusion of iron in its crystal form. And it is yellow when it is hydrated. And this, if this red and yellow soil is fine grained, then it is generally fertile. And if it is coarse grained, then it is not fertile. They are also poor in nitrogen, phosphorus, and humus. Basically, every type of Indian soil is deficient in phosphorus. Now moving on to the next one, which is laterite. It is derived from a Latin word means later, which means brick. It is generally used for brick making. Develops in an area of high temperature and high rainfall. So in the high rainfall region, the minerals in this soil is leached down. So the compound left in the soil are iron oxide and aluminium. So it is rich in iron oxide and aluminium. And humus is removed. Humus content in this soil is removed. Why? Because this is in the high temperature region. So these soils are poor in organic matter, mm, organic matter, nitrogen, phosphorus, calcium. These are lacking in this soil, and it also contains the potash. So this laterite soil, it is found in Tamil Nadu, Andhra, Kerala, and suitable for the crops like cashew nuts. Next comes the arid soil, which is sandy in nature and saline. Found in the region where temperatures are high and rainfall is less. They lack moisture and humus. Nitrogen is also insufficient. Phosphate content is moderate. And it also contains the concords. Next comes the saline soils, that is ooser. That is, they are not so fertile or infertile. It contains sodium, potassium, magnesium. And due to the excessive irrigation in the alluvial soil, it is also becoming the saline soil due to the capillary action. Next one is peat, found in the areas of high rainfall and high humidity. It contains large amount of dead organic matter. organic matter is high, which leads to high humus content. It can go up to the level of 40 to 50%. These are generally black in color, and it occurs majorly in part of northern Bihar, south of Uttarakhand, coastal areas of West Bengal, Odisha, and Tamil Nadu. Next comes the last is forest soil. As the name suggests, this soil is found in forest area, in mountainous regions, and this vary from region to region. So this is all from my side. Now, if you like the video, hit the like button and subscribe the channel and share it with your friends. And also, if you have any suggestions, mention the same in the comment section. Thank you for watching.